The following program is part of Cable in the Classroom, a service of the cable television industry and your local cable company.
You're not going to need this for the next 30 minutes.
The second law of thermodynamics?
What was the first law?
I don't know. Hey, welcome to SportsFigures,
On ESPN 2,
where sports and science go one-on-one,
where physics get physical,
where math gets mathematical.
where sports figure.
Go figure.
It's SportsFigures.
Now, this is your main ripcord here, and this is your reserve. Understood?
Main, reserve. Got it.
Good. And here on your wrist is your altimeter. That'll tell you how high you are.
Got it.
All right, you ready?
Yes.
Let's do it. Countdown to 10 seconds. Now remember to pull your ripcord at an altitude of precisely 914 meters.
Okay.
All right, you're off. Remember, 914 meters.
914 meters. 914 meters. 914 meters. Meters? How many feet is that? Feet to meters. Feet to meters. Let's see, multiply by 30. 100 centimeters in a meter times. 3,000 feet.
This is a yard.
Chris, actually, that is a yardstick.
Right. 3 feet or 36 inches, right?
Right, and it hurts. But did you know that since 1893, the American yard was legally defined as .914/40183 of a meter? That's crazy, isn't it?
Yes.
For over 100 years, the legal system of measurement in this country has been based on the metric system, and we don't even know how to use it.
So let's join Kevin Flynn with Skysurfers Troy Hartman and Vic Pappadato at ESPN 2's X Games. Let's dive into some metrics.
If you were a sky surfer like Troy Hartman here, you'd want to make sure your parachute opened the right distance from the ground. But how would you know what that distance is?
A rose by any other name would still smell as sweet. Shakespeare said that, and he was right. I mean, if he had called this a sewage treatment plant, it would still smell like a rose.
So what do Shakespeare and roses have to do with units of measurement? Absolutely nothing. The point is that units of measurement are simply a name that we apply to an arbitrary length or mass, temperature, whatever. $25 bajangos.
Kevin, what's a bujango?
A bajango is 3 jujus, 13 ubanjis to the juju.
But how long is it?
I told you, 25 bajangos.
Yeah, but how long is it in feet?
A bajango is 3 feet, so 25 would be 75 feet.
So why didn't you just say 75 feet?
Because I was measuring in bajangos.
Django.
Originally functioning not bajangles. Sure need what first history for the condition even für Schniedern, Schneeren, jeden Faden Höden, für Schniedentaten, für die Art für Schniedet. Für den Hödet, für Schniedet, für Nadet, für Bodet Schniedet.
Guess where the measurement foot came from? Or maybe you've heard of a horse being so many hands high. In the old days, they used to use a unit of measurement called the cubit. The cubit was the length of your forearm, anywhere between 18 to 20 inches. But the problem with that was pretty obvious. Everybody's measurement was different. I'll have 1 foot-long hot dog, please.
There you go, sir.
He has very small feet. But it really doesn't matter what a unit of measurement is called, as long as everyone involved understands what is meant and is operating on the same scale. Ouch! Enter the metric system. You knew I was getting to that, didn't you? The metric system is also known as SI, which stands for Systems Internationales de Unites, which in English means International System of Units. But the French way of saying it's so much cooler. Besides, it was a Frenchman who invented the metric system. It was also in France where they first pioneered the sport of sky surfing. Coincidence or not? Troy Hartman and Vic Pappadato are definitely contenders here at the 1996 X Games. They came in first place at the 1996 SSI Destination Extreme competition in Sebastian, Florida, and second place at the SSI competition in Spain. And I got to hang out with them before their first jump. So you guys really have to watch your altitude up here, huh?
Right. Being constantly aware of your altitude becomes second nature to a sky surfer because you have to make sure you have time to open your parachute, and just in case your main fails, you want to be able to open up your reserve in time.
Now, what if you guys were sky surfing in Spain, where they use the metric system? Would that mix you up?
Well, the pilot would tell us to exit the aircraft, and we'd look at our altimeters, and they would say 13,000 feet. And the person next to us might say 4,000 meters. It's time to get out, regardless.
You're not up there doing all kinds of metric conversions.
No, we just bring our altimeters from home, and they're in feet. It's what we're used to.
So what you're saying is altitude is really more just a feeling, whether it's English units or the metric system.
Absolutely.
All right, guys. We'll have a good jump.
Thanks.
Take it easy. You see, most of us experience measurement by feel or by relation. And we're all used to buying soda in liters. When you buy a big 2 liter of soda, you don't convert it from milliliters into quarts. You just know that 2 liters of soda is a lot of soda. I'll show you what I mean. Hey, how tall are you?
About 5 feet 8 inches.
5 feet 8 inches, that's 68 inches or 1.72 meters. You're 1.72 meters tall. Now, how tall is this pole?
About 2 meters.
2 meters. Bada bing, bada boom. We're using the metric system. Hey, how long's your hand?
About 5.5 inches.
5.5 inches, that's 14 centimeters. So how long's this banana?
About 15 centimeters.
Okay. So how long is this banana now?
Between 7 and 8 centimeters.
How simple is the metric system?
Pretty simple.
How simple?
Pretty simple.
How simple?
Pretty simple.
Is it simple?
Yeah.
The metric system's simple. So, if you just create a point of reference, you can start using the metric system right now, right this minute. Hey, 182 centimeters. The great thing about the metric system is how easy it is to convert from one unit to the other, because it's all based on 10. 182 centimeters is 1.82 meters or 1,820 millimeters. If we started doing this with inches and feet and 1/16 of an inch, forget about it. We'd be here all day. If this is 6 feet, that's 6 times 12 inches, which is 72 inches. Times 16 is,
So let's take a look at how the metric system works. The metric system breaks down into a series of prefixes. Milli means 1,000th of, centi means 100th of, and deci means 1/10 of. Kilo is 1,000. Now there are a few others, but those are by far the most common. These prefixes are attached to the units of measurement. For length, we have the meter. For mass, we have the gram. Heads up. For volume, we have the liter. Now again, there are others, but these are the most common. The prefixes are attached to the units to quantify what it is you're talking about. Whoa!
Ouch. So a millimeter is 1,000th of a meter. A centigram is 100th of a gram, and a deciliter is 1/10 of a liter. Simple, right? You just add the prefix to quantify whatever unit of measurement you're talking about.
That plane is 1 kilometer up. That's 1,000 meters, or 10,000 decimeters, or 100,000 centimeters, or 1,000,000 millimeters. Try figuring out how many 16ths of an inch in a mile. Let's say Troy makes his jump from 1 mile up and he needs to open his chute after falling 2,000 feet in order to land safely. Falling at 180 miles per hour, he needs to figure out how long his routine can be before he has to pull his chute. Well, the first thing he'll have to do is convert miles per hour to feet per hour so that he can figure out feet per second. In order to do that, he has to know how many feet in a mile.
How many feet in a mile?
500? I don't know.
Over 3,000, I'd say. Is that right?
5,552? Close.
Well, let's say he actually knows there are 5,280 feet in a mile. Now he has to multiply 180 miles per hour by 5,280. Not a simple calculation when you're falling out of the sky. By the time he's got it figured out, it may be too late. But let's say Troy is jumping from 2 kilometers up, and he knows he has to open his chute after falling 1,000 meters. Falling at 289 kilometers per hour, he has to figure out how long it will take to drop 1,000 meters. First, he has to convert from kilometers per hour to meters per hour. There's nothing to it. You just slide the decimal point over 3, because there are 3 zeros in 1,000. That gives him 289,000 meters per hour. Divide by seconds in an hour, 3,600, and his rate is approximately 80 meters per second. So he'll have to open his chute after about 12 seconds. As you can see, the metric system is the fastest way to figure it out. And when you're jumping from an airplane, time counts. So forget trying to convert from one system to the other. Just think in metrics, and pretty soon, it'll be second nature.
182 centimeters.
Ha! Viva la System International de Unites!
I'd like to thank Troy Hartman, Vic Pappadato, the X Games, and the students for helping us out today with Skysurfing and metrics. Sounds good? Whoa.
Thanks, Kevin.
Yeah, thanks, Kevin.
Sports Figures, explanation of the rules, the working of the universe, the research and its tools. Sports Figures, we take you up in the air, on the ice, in the field, gonna put you right there. Sports Figures, we got the players you know, with examples from the game, we help your mind to grow. Sports Figures is something fresh, not the same. Sports Figures, we put your brain on the game.
You are watching Sports Figures. Where were you?
You get that last part?
I think so.
You forgot to carry the 2.
Hey, cut that out. Your own paper. Quit cheating.
That's it for today on ESPN2's Sports Figures.
Thanks for watching, and we'll see you next time.
On ESPN2, Sports Figures.
Doink. Well, guess we won't be needing this anymore.
We're done.
You want it back?
All right. You can have this back now. Thanks for watching. Go. It's over. ESPN2 Sports Figures is presented commercial-free for educators to record and use. Curriculum guides are available to help integrate sports figures into your classroom. For more information, call your local cable system or Cable in the Classroom at 1-800-743-5355. You can also access Sports Figures lesson plans by connecting to the ESPN Net Sports Zone at the internet address on your screen. ESPN2 Sports Figures makes math and physics a ball.
The preceding program is part of Cable in the Classroom, a service of the cable television industry and your local cable company.